Yeah, we can start.
Okay, hello. A very good evening to all the viewers live here. Uh, we are ready to start with our MCQ discussions on the topic parenterals. So one by one, we'll be solving and looking at the MCQs along with the options, and we'll discuss कि क्या सही हो सकता है and why it is right and कौन से options गलत है या how do we tackle questions. Okay. Uh, so we'll attempt the test. Okay, so we have our first question. The first question says intramuscular depot injections should have the following rheological characteristics. So this question is based on fluids. What is the rheological characteristic that intramuscular depot injection जो होता है उसको कैसा होना चाहिए? So we have four options. First is the dilatant, thixotropic, rheopectic, and shear thickening. So before attempting, we should know firstly कि ये जो चारों है, what exactly does it means? So if you look at the options, first is the dilatant. So dilatant behavior is ये सारे जो है there are examples of non-Newtonian fluids जो behaviors है. So dilatant is one जो जिसका viscosity it decreases when we apply the shear stress. And thixotropic again is a behavior where the viscosity जो होता है fluid का it is more, but as in when we start applying the stress or start mixing it or that kind of thing, so it's the viscosity decreases along with it. And rheopectic is a behavior जब starting में उसका viscosity कम होता है, but as an on when we apply the stress, so the viscosity increases. And the last one simply says shear thickening behavior. So intramuscular, if we say, so starting may the formulation itself is in more of highly viscous, not highly matlab, it's comparatively viscous, and to our putting या इंजेक्शन अप्लाई करने के लिए पहले we need to shake it a while. So जब हम stress apply करते हैं तो उसका viscosity decrease हो जाता है, and once the viscosity is decreased, then it becomes more easy for us to inject this injection. So the answer for first is thixotropic. We'll move on the next. So class 10,000 area is referred as what? So firstly we'll understand what class 10,000 is. So जब हम parenterals की बात करते हैं तो obviously parenterals are more of pyrogen free, they should be sterile, all those things comes in a picture when we say is parenterals, right? So जो parenterals का manufacturing होता है उसको भी we need to prepare in such a way जहाँ पे वो पायरोजन फ्री हो, उसमें वो स्टेराइल हो जो प्रोडक्ट. तो हमारा जब प्रोडक्ट तभी स्टेराइल होगा जब हमारा जो मैन्युफैक्चरिंग एरिया है वो स्टेराइल हो, राइट? सो अकॉर्डिंग बेस्ड ऑन दैट जो पेरेंटल्स का मैन्युफैक्चरिंग फैसिलिटी होता है, इट इज डिवाइडेड इनटू वेरियस क्लासेस. These classes are given as numbers. So if I say class 1000, class 10,000, class 1 lakh, so there are different classes which has been distinguished. So classes किस basis पे है? When I say class 10,000, so it means that complete area, that area should not have more than 10,000 particles in that specific area. उसका जो unit होता है that is cubic per centimeter or feet, sorry. So उसका जो unit है is it's cubic foot, and it says that in that particular area the particles should not exceed more than 10,000 in number, and also it has a limit on the particle size. जो size होती है वो भी specific limit से ज़्यादा नहीं होना चाहिए. For example, 0.3 माइक्रॉन से ज्यादा नहीं होनी चाहिए पार्टिकल साइज. तो 0.3 के माइक्रॉन्स के साइज के 10,000 particles are allowed in that area, उससे ज्यादा नहीं होना चाहिए. So if these conditions are met, then we consider that area as class 10,000 area. Similarly, if I say 1,000, तो 1,000 से ज्यादा नहीं होना चाहिए, 1,000 से ज्यादा particles. When I say 1 lakh, तो फिर 1 lakh से ज्यादा particles नहीं होना चाहिए. So it depends on what exactly the operation would be carried out in that particular area. So over here they have asked class 10,000 area is referred to as what? So the options are buffer area, clean area, aseptic area, or all of the above. It cannot be all of the above because it depends the operation क्या है. तो area का नाम जो है वो operations के हिसाब से दिया हुआ है. So I'll the answer for this is buffer area, because clean area can have more particles मतलब जो नंबर होगा वो ज्यादा होगा and aseptic और कम होगा. So the answer for this is buffer area. Okay. The tolerance of particulate matter in excess of 100 microns in diameter in large volume intravenous solution is what? So we need to understand that there are two types of parentals if we differentiate based on quantity. So one is LVPs and SVPs. SVPs are small volume parentals and LVPs are large volume parentals. So whatever the volume or quantity is, we should always understand that this dosage form is going directly into our veins, right? So it should always it should not have any particles in excess of 100 microns that could cause blockage in our blood capillaries. So the answer for this is 0, because if there is any particle who is in excess of 100 microns or any big particulate matter, it shouldn't be a part of intravenous solution. We should always have 0 particles with 100 microns. So the answer, okay. The following solvent is a water immiscible non-aqueous solvent. So we have 4 options, and in this 4 we have 3 of the 3 options which are water miscible and one is non-miscible. So we need to identify which of the one is more water immiscible. If we look at the options, deoxylanes is oxalanes, dioxalanes is more of water miscible. We have it's a specific class which has different other solvents in it. PG 400 is the most commonly, I believe, is everyone must have used. It's more of water miscible. Butylene glycol again जो है वो water miscible है. Isopropyl myristate is one option in this, which is example of water immiscible non-aqueous solvent. So the answer for this is C, and we'll move on to the next question. For sterility testing, which of the following media is used? Okay, so just to give a heads up, sterility testing हम कैसे करते हैं? There is a plate, agar plate जिसमें हम जो मीडिया है होता है उसे पहले सेटल करते हैं, देन उसके बाद में जो हमारा सैंपल होता है उसे हम there are different ways जो हम वो अगार प्लेट के ऊपर हम उसे ड्रॉ करते हैं, and then we keep it for microorganisms grow होने के लिए हम उसे time देते हैं. So which is of the following media is used for sterility testing? So for answer for this is soya bean. I don't know why option 4 is only A. It's also means the same thing, but if we'll go to the more specific one, it is soybean casein digest, which is the media that is used for sterility testing. Okay, we'll move on to the next question. Did we skip on 6? Yeah, okay. So which of the following is not correct regarding the angle of injection? We know there are different kinds of injections that is given. So there is a specific degree जो angle पे हम inject करते हैं. So which of the following is not correct according to this 4? So if we see intradermal, which is given जो हम skin के ऊपर दिया जाता है, so that's the first 15 degrees, that is correct. Intravenous again 25 degrees पे दिया जाता है, again correct, because we cannot give it 90 degrees straight, right? So there is a specific way where we how we inject the injection. Subcutaneous 45 degrees, correct. Intramuscular 50 degrees, this is the one which is incorrect. Intramuscular is not given at an angle of 50 degrees Celsius, 50 degrees angle. Okay, we have given the 7th. Moving on to the 8th question. Regarding the parenteral formulations, which of the following is false? So we need to identify which of the given statements is not the correct one. When first option says parenteral formulations are sterile products. Yes, it's true. Parenteral formulations should be sterile 100%. Second question says parental formulations must be pyrogen free. Yes, true again. It should not have pyrogens, because pyrogens may lead to side effects. So obviously parental formulation should be pyrogen free. The third one says the majority of the parental formulations for human administration are multi-dose formulations. I kind of disagree with this statement, but let's check the fourth one also. The vehicle of choice for human parental formulation is water. Again, this fourth statement is correct because the blood inside the body is water miscible, so it should always have the vehicle of choice is water. So the answer for this, the false statement here is the third one. Because there is no specific डिस्टिंग्विशन या फिर कि हमें इसे मल्टी डोज ही बनाना है या फिर सिंगल डोज ही बनाना है. अकॉर्डिंग टू द नीड, अकॉर्डिंग टू द यूज एंड अकॉर्डिंग टू द ड्रग, द फॉर्मुलेशंस आर क्रिएटेड. मार्केट में सिंगल डोज एंड मल्टी डोज दोनों फॉर्मुलेशंस अवेलेबल है. देयर इज नो स्पेसिफिक percentage or majority which can be which can be accounted for based on कि क्या majority or minority hogi. It's purely based on the drugs that is being used and the use that is required. So the answer for this is answer 3 or option 3. This is the false statement. Okay, move on to the next. The amount of dextrose isotonic with blood plasma. We use dextrose in blood plasma in the parental formulations, mostly in LVPs or large volume parenterals. So firstly we need to remember that जो भी हम parenterals inject करते हैं या फिर जो भी हम body में directly देते हैं, it should be isotonic. I hope you all know isotonicity. Isotonicity is one topic or is a thing where we cannot the injection or the thing, that substance or the dosage form or formulation that we're injecting into our body, it should be compliance or should have some kind of equilibrium with our body fluids, because if it's not, then it would it can show some kind of side effects or the body may reject it. Or when agar wo isotonic nahi hai to fir there are chances ki body will show some kind of reaction to that fluid when we enter. So always the kind of the parental should be isotonic with a blood plasma, and to adjust the tonicity we use most often dextrose. So what amount of dextrose is used? Or so we have 4 options. It is 5% weight by weight. It is not the two things playing here are the unit first thing and the quantity. So we have 5% weight by volume and weight by weight, 2 options, and 0.5% weight by weight and volume by volume. So dextrose is a solid content, so you should always remember when a solid is mixed into liquid, it is always weight by volume. When a solid is mixed into solid, then it is weight by weight, and if it's liquid mixing into liquid, then it is volume by volume. So here dextrose, if we consider it's a solid particle and it is getting mixed with a liquid, so the first we need to confirm is that the unit is weight by volume. So we have 2 options with weight by volume, option 2 0.5% and option 4 5%. So the answer here is 5%. 5% dextrose is used to adjust the tonicity with the blood plasma. Okay, question 10. Cryoprotent used in freeze-dried parenterals. Okay, so what is freeze-dried parenteral? I'll give you a gist. Freeze-dried parenterals are ones like if a drug is subjected to be given parenterally, but it is not that much stable in if it's readily made या फिर injection volume में उससे बनाते हैं, it cannot be stable, या फिर it is उसमें कुछ आगे जाके impurities form हो रही हैं, those kind of thing, or या फिर drug degrade हो रहा है. So there are such drugs available in nature which cannot be readily given. So उसका क्या करते हैं, we make those parenterals in freeze dried method. या उस मतलब क्या होता है, we mix it first, we make a solution of it, then उसके बाद solution बनाने के बाद में उसका जितना भी liquid होता है उसको हम फ्रीज ड्राई करते हैं, वो लिक्विड वहां से निकल जाता है. तो हमारे पास फिर उसका सिर्फ जो सॉल्युबलाइज हो चुका था ड्रग, उसका हमारे पास फ्रीज ड्राइड प्रोडक्ट रहता है. बट अगेन फ्रीज ड्राइड में भी देयर इज वन थिंग लाइक इट कुड डिग्रेड और दोस काइंड ऑफ थिंग. मतलब जब हम उसे इतने कम माइनस डिग्रीज पे लेके जा रहे हैं तो देयर आर चांसेस कि वहां जाके वो अगेन there can be some kind of instability which can be produced. So for that we use cryoprotectants Cryoprotectants again are kind of excipients, a class of excipients that is used. So we have options: trehalose, mannitol, glycine, sorbitol. Mannitol, yes, mannitol is also sometimes used as a cryoprotectant in freeze-dried parenterals, but the more specific and more widely used is trehalose. Why trehalose? Because trehalose is more of stable as compared to mannitol. If we consider using it as cryoprotectants, then also trehalose is one excipients which avoids the growth of particles or those kind of thing. Just to if I have to summarize, I'll say trehalose is more of stable than mannitol, and glycine sorbitol are, I believe, are not that much used as cryoprotectants. So the answer for this is trehalose. We'll move on to next one. Water. Question 11. Water which is free from pyrogen is given below except. So we need to identify which of the options given are not pyrogen free. So bacterio, water for injection, we have SFWI. All the first three options are water for injections, and we should always remember water for injections are specific water which is sterile and which is obviously free from pyrogens. So purified water is one example which we do not directly use in for injectables because it may have pyrogens. So answer for this is option B, purified water. Okay, moving on to the next question. It says sulfur is used as what? So sulfur is a material again, and the options says the surface coating material of glass containers. No, it is not used as that. Option 2 says additive in manufacturing of leaching proof plastic containers. No, this is again a wrong option. Option C says vulcanizing curing agent in rubber closures. Yes, this is the answer, because sulfur adds on when we sorry, sulfur is more of providing strength in when we add sulfur, it provides more of strength to rubber closures, and it is more of providing stability to the rubber material. So it is the answer for here is option 3. Sulfur is used as a vulcanizing and curing agent in rubber closures. So moving on to the sorry, I missed two questions. Okay, question 13. According to IP, the preparation passes the rabbit pyrogen test if. So rabbit pyrogen test, the synonym for this is LAL test, LAL test. This is a specific test which is used to identify if the formulation contains pyrogens, yes or no. So LOL test is also known, LAL test is also known as limellus amebicide lysate test, where that is also a method to to identify the pyrogens. So for according to IP, we what we do is the preparation, uh, the preparation or the formulation that is being will be examined is being injected into the rabbits. And to pyrogen is one thing. If pyrogens enters in our body, what happens is it leads to uh, a feverish kind of thing. So what happens is happens in fever is the body temperature goes up. So similar thing will happen in rabbits. So if we inject the injectable into the rabbit, and if the formulation contains pyrogen, so what will happen is the rabbit will get a kind of fever. And what happens is happen in fever, as I said, that the temperature of the rabbit will go up, the body temperature. So जब body temperature up जाता है तो हमें automatically समझ में आ जाएगा the formulation के अंदर it has pyrogen. So there are specific terms and conditions, like when should we understand that ki उसमें pyrogen थे या नहीं थे. There is a group of rabbits that has been taken. So the option first say the group of rabbits, 3 rabbits does not exceed 0.6 Celsius. This is not the correct one. Option B says the group of 3 rabbits does not exceed 1.4, and if the response of individual rabbits is less than 0.6. So this is the more accurate. If आप जाके IP में देखोगे, so एक सारे specific terms and conditions दिए हैं कि when can we consider that the formulation is pyrogen free if the temperature of the rabbits meets this criteria. Hence we can conclude that the formulation does not have pyrogen. So based on the formula options that we have, so this is the option which is also mentioned in the IP. And if the group of 3 rabbits cumulative does not exceed 1.4 and individual rabbits ka temperature is less than 0.6 Celsius, hence we will consider or conclude that the formulation does not have pyrogen. Moving on to the next question. Uh, the parental preparation is called small volume parental if the volume loading capacity is dash. So as I have already spoken in one of the MCQs, there are two types of parenterals, SVPs and LVPs. So if the volume or the quantity of the parenteral is less than 100 ml, so then we'll consider it as SVP, and if it's more than 100 ml, then we will consider it as large volume parenterals. Question 15. Which of the following operation is performed aseptic area? So aseptic area again is an area which is designated in the manufacturing facility of parenterals. So we have the options: compounding of product, process, filtration, aseptic gowning of personnel, and aseptic filling. Compounding of product is a more where the product is been compounded or manufactured, so it requires more. Only it cannot be only aseptic, but more considerable or more, it should be pyrogen free and those kind of things. So it is more focused. I'm sorry. Process filtration. Filtration again is a press or a method where a step which is there when we manufacture or where we make the parenterals. Aseptic gowning of personnel, no. Gowning is again a process where the scientist or the person or the operator will be going in gowns himself because the body cannot be exposed into the area directly. An aseptic filling. So aseptic filling is the right option because the area for filling inside the primary packaging material should be aseptic. So aseptic filling is performed in the aseptic area. Okay. Angle of insertion with skin in case of IV route is what? IV intravenous. So there is a particular angle uh, from where the physicians or the doctors insert the injection into a body. So the degree is around 25 degrees, the angle. Okay. This is specific for IV, IM, and those kind of the injections, subcutaneous or intradermal, those kind of injections, and different angles through which it is inserted. LAL test, as I said, that along with rabbit pyrogen test, LAL test, it's not a synonym, but it's also one of the tests which is uh, used for identifying the pyrogens in the formulation. So LAL test is used for testing the following parameter. The four options are sterility testing, pyrogen test, leakage test, and rapid test. As I said, it is more of to check the pyrogens in the formulation. So answer is option B. Moving on to the question 18th. Verticular laminar flow hoods are required to protect personal and environment from. We have four options. We all know what vertical laminar flow is. It's a kind of box or a chamber where the air moves in a specific direction. So verticular laminar airflow means it is the air is moving vertically in only one direction. So why it is used, and it is used for protecting what? Infectious materials, noxious chemicals, anti-neoplastic agents, or all of the above. So answer is all of the above because we need to keep aside, or the formulation or whatever work we are doing, it should be free from each and every toxic material or any kind of material that can make the formulation unstable. So it should be from all of the above. Moving on, the next question, the second last question, it says, which of the following is not an official test for rubber closures? We should always know that rubber closures are used on multi-dose vials. So which of the following is not an official test? First is sterility test. Yes, it should be 100% sterile, because if the package, it is directly in contact with the formulation. So if it's not sterile, then again it could also make the product unsterile. So it should be sterile. So it should sterility test is one official method. Humidity test, it is kind of odd option here, because rubber closures, when we talk about rubber closures, we do not mostly talk about humidity. Fragmentation test, yes, because we are constantly, as I said, it's a multi-dose vial, so obviously we'll penetrate the injections more than 1 or 2 times. So if it's the उसका fragmentation ज्यादा है, तो फिर वो जब हम penetrate करेंगे, तो there are chances कि उसके जो रबर के particles हैं वो भी हमारे formulation में चले जाए. तो ऐसा नहीं होना चाहिए. Hence it should pass the fragmentation test. It should be more of healthier. So fragmentation test, yes, इसे pass करना पड़ेगा. Cell sealability test, again, yes, it's an official method. The importance here is कि जो जब हम इंजेक्ट करते हैं एंड जब हम उसको बाहर निकाल देते हैं, there is a formation of a hole inside the rubber, right, the closure. So it should have the उसका एक फीचर होना चाहिए कि जब हम उसे इंजेक्शन बाहर निकालते हैं, it should get self sealed. Because अगर वो self sealed नहीं होता है, तो that means it would be in direct contact with the environment, which is not desirable. So self sealability test is again a official test. Humidity test is the one which is not official here. Question 20, the last question. The following test evaluates treated soda lime glass chemical resistance. So treated soda lime glass means we are talking of type 2 glass here. We are just to give a brief idea, there are 3 types of 4 types, but for parenterals mostly we use 3 types: type 1, type 2, type 3. So type 3 is soda lime, and treated soda lime is type 2 class type. So if you talk about official methods which is used for glass containers, in parenterals there are 2 types: water attack test and powdered glass test. Sulfuric acid test and fused glass test is not an official method, or which is used for glass containers in parenterals. So if we read the question again, it says specifically treated soda lime glass chemical resistance. For treating, when we treat the soda lime glass, so that the soda doesn't get leached into the product, hence we treat it. So we need to understand the chemical resistance of the glass after the treatment is done. So how can we do it? It's done by powdered glass test. So what happens is the container is firstly crushed, and then it is subjected into the liquid media, and then the media is subjected to chemical testing or analysis. After that, what we can consider is we can identify that kitna chemical resistance hai and kitna nahi hai. So the answer for this is powdered glass test. So this is the questions. Okay, so these were the 20 questions that were discussed along with the answers. I hope I was crisp and clear. So with this, we end our session. Thank you all for joining. Have a great rest of the day and the weekend. Thank you.